One of the guaranteed questions in paper 1, AQA A Level Chemistry, is a question about gas equilibria and calculation of Kp. This is a past paper question from 2024. And in the first question, they provided you with a gaseous reaction, equilibria, between steam and carbon monoxide to give hydrogen and carbon dioxide. The first question, they told you the initial moles of both water and carbon monoxide, which are the reactants, and then the equilibrium moles of the hydrogen, one of the product. And they want you to calculate the mole fraction of the hydrogen gas in the equilibrium mixture. So we know that from the balanced equation that 1 mole of each will give you 1 mole of each of the product. That means that the number of mole of hydrogen at equilibrium, as they say, is 0.92. And that means also this is the same number of moles produced from carbon dioxide. And then we can calculate the moles of both the water and or steam and carbon monoxide at equilibrium. So that will be the total minus the 0.92. So it's 1.08. And that applies also for carbon dioxide, 1.08, because it's 1 mole to 1 mole. So that means the total moles of all the gases at equilibrium will equal 4 moles. Now, the mole fractions of hydrogen will be the moles of hydrogens at equilibrium, which is 0.92 over the total moles, which is 4 moles, and that will give you 0.23. So this is the mole fraction of hydrogen. The next question states why the equilibrium constant Kp for this reaction has no units. We can see that the number of moles of the products equal the number of moles of reactants, which means that the units will cancel out. So simply state that the number of moles, the total number of moles or the number of moles of reactants equals the moles of products. Equal the number of mole, the total number of moles of products. That means these will cancel out. The temperature of the equilibrium mixture is increased. How does the amount of the product, which is hydrogen, change when the new position of equilibrium is reached? We know that the effect of temperature depends on which side of the equilibrium is endothermic, which one is exothermic. If the temperature increases, the equilibrium will be pushed towards the endothermic reaction because this is the forward one is exothermic, which means that less of the products will be produced. So here the amount of hydrogen will decrease. Then they ask you now to calculate the Kp for another reaction where there is ethene react with steam to give ethanol. And they give you the mole fractions of all of the reactants and products at equilibrium. And also they give you the the total pressure, which is 600 kp. So we need now to calculate the partial pressure for each of these reactants and product and put the Kp in the correct expression and calculate the value. The partial pressure of each will be the mole fraction of each multiplied by the total pressure. And the Kp value will be the partial pressure of the products, which is ethanol, so partial pressure of ethanol, divided by the partial pressure of the ethene times the partial pressure of the steam. Remember that this reaction is 1 mole of each to give 1 mole of the product. So it's all, there's no, it's not raised to any power. So now we need to calculate the partial pressure. As we said, it will depends on the mole fraction. So for ethanol, it's 0.0321 times the 6,000 And for the ethene is 0.645 times 6,000, and then times also the partial pressure of steam, which is 0.323 times 6,000. And when you do this calculation, you're going to see that the final answer is 2.56 times 10 to the minus 5. And the unit here is going to be kilopascal minus 1, because there is 1 kilopascal at the top, 2, and then kilopascal for both of the products. So the unit kilopascal minus 1. And the final question to state the effect of any of an increase in the volume of the container on the value of Kp for this reaction at constant temperature. Remember that increasing the volume means there is a decrease in the pressure, and the pressure doesn't affect the value of Kp, the same as the concentration on Kc. So in this case, there is no effect. So you just need to state that there is no effect on the value of Kp for this reaction at equilibrium.